And welcome back one more time to Unit 9, and we are talking about buoyancy right now. And what exactly is buoyancy? Well, basically, to sum it down, if you've ever been swimming, you understand buoyant forces, or at least a little bit about buoyant forces. For example, I'm rather a hefty little fellow. Mr. Cole here, L. Turdford, 67. I weigh approximately 220 pounds. Well, I'm a hefty guy, which means if one of you decide to come grab me and pick me up, you would have to lift with at least 100 or at least 220 pounds. But yet, if we were to go over to someone's swimming pool, not my house, I don't have a swimming pool, but that's because, well, I don't swim, so the pools kind of make sense. Actually, I would like to have like a big kiddie pool or something. That'd be great. But if you decided to try and pick me up in water, you would find out it'd be very easy. One of the smallest people in the class could lift me in the water. Why could they lift me while we're in the water? Well, here's the thing. If I'm in water, the water is already lifting me. So you're just going to have to lift me with the difference. So I still weigh 220 pounds. Even when I'm in the water, I still weigh 220. But the thing is, for you to pick me up wouldn't take 220 because the water is going to exert possibly 150 pounds against me, and so all you've got to do is lift me up. Now, that's what buoyant force is. It's this force of the water that's lifting something. And it's not just water. Everybody starts thinking, my chair is so squeaky. Everybody just think buoyant forces are about water. It's about a fluid. It's not just water, and that's where everybody gets messed up. Buoyant force has to do with you being in a fluid. A fluid is anything that can flow. Well, what if somebody goes home and they decide to fill their swimming pool, oh, I don't know, with gasoline? So they fill their swimming pool full of gasoline in an effort to try and get ready for another Cold War ahead. Anyway, so here you go. You get in the swimming pool. Probably not a good idea to be in the swimming pool full of gasoline. But anyway, that's not the point. You filled your pool with gasoline and jumped in. There is a high probability that you might end up sinking in the water. That's because gasoline would not exert as much of a buoyant force against you. So why would gasoline not exert as much buoyant force against you? Well, how about this? What if you went to a salt lake like in Utah? Even I cannot swim at all. But if I go to Salt Lake, I have no problems. Heck, I go to Salt Lake, I'm probably going to be having a great time. I'm going to be laying out on my back, catching some sun, trying not to get pickled in the water. But the difference is, it lifts with a huge buoyant force against me. Now, wait a minute. What's different? I didn't lose weight in any of these. So what is different about salt water, gasoline, and then let's say, for example, just plain old water up here? What is the difference between all these things? Well, it's simple. You have to look at the density of the fluid. You've got to look at the density. The density determines how much something is able to lift you. Now, here's what most people don't think about. Wow, and I just shot my red pen across the room. So I might actually have to like pop up and retrieve that. City air. I'm having to Google something real quick because even it's not on the top of my head. Da, da, da. So I'll just sit here and hum a little song. Approximately 1.225. Here you go. This is one that most people don't even think about. Right now, here we go. Standing on the ground. You are actually being lifted right now. You are under a buoyant force. If you, right now, unless you're standing in a vacuum, there's a buoyant force upon you. There is? That's right. Because this is what most people don't recognize. You are surrounded by a fluid right now. I'm surrounded by a fluid? You dang right you are. You're surrounded by air. And air has a density of 1.225. kilograms per meter cubed. And so the density, now that's the reason why. The air is not lifting you. Well, let's look at water. Water's got a density of 1,000, which is why water is able to lift you and you know it, as opposed to air, which has a very small density. But still, the reality is you are currently subjected to a buoyant force at this time that has to do with the fluid that you are in. So obviously the equation for buoyancy has got to have something about density in the equation. The density of the fluid has to be present. Essentially, if you're looking for a textbook definition, and if you've wondered what has he drawn on this paper, it's a bathtub. And so let's have a bathtub completely full of water. And all of a sudden, you decide to jump into the bathtub. Well, I know as a kid, more than once, I flooded my mom's bathroom because I was too dumb to understand this concept. What would happen if I were to jump into the bathtub? And I mean go completely under the water, as in I am in that bathtub completely under that water. Well, if I get in that bathtub, I'm going to push all this water out. The definition of buoyancy. And here you go. I'm displacing this water. If you could weigh this water that I pushed out, the buoyant force is equal to the weight of water an object displaced. Oh, that was sexy. Let's say it one more time. Buoyant force is equal to the weight of the water that I displace. So in other words, it is equal to the weight of the water that I displace. And so what happens is we'll just replace mass with rho v, density. And so the equation for buoyancy, and I know I've went in a huge roundabout way to get there, the equation for buoyancy is just rho vg. Fluid, gravity. And there's our basic equation for buoyancy. And I'm going to stop this video here. This one was just an introduction to get you used to it. But what you always need to focus on is what is the fluid. Buoyant force is directly proportional to the fluid something is in. Is it in gas? Fine. Give me the density for gas. Is it in salt water? Fine. Give me the density for salt water. Regular water? Fine. Give me the 1,000. Is it in air? And you don't think about us being lifted by air. But you'll work problems with a balloon, and the balloon is being lifted up by air, by the same principle. So, anyway, here's where we're getting at in this problem. And I'm going to come back. I'm going to do the examples in the next couple of videos.